Here is the next example. In this example, it's a delta-wye connection. Okay, three-phase balanced 208 volt. We know that 208 volt is line-to-line voltage. Has a line impedance or load impedance of 5 plus J2 ohm. Okay, find the power consumed by the load: active power, reactive power, apparent power. P is the active power, Q is the reactive power, S is the apparent power. Also power factor of the load. Here he's saying that ignore the line impedance. So I'm going to draw the system, a three-phase system. Since there is no line impedance, it should be easier. Okay, at the same time, the given voltage, we always take that as a line value until unless he specify. Okay, so make sure B connected to B, C connected to C, A, B, C. I always follow the positive phase sequence here. So this is the given system. Now to find out the current passing through the system, I need to find the current so that I can find the power. P is nothing but square root 3 times VL IL cos theta L, since I'm finding the load. Here, since there is no line, it must be equal to the source too. Or I can use 3 times VPH IPH cos theta L. Cos theta of load, where it's not line. Okay, so cos theta of load equal to R over Z. I have R equal to 5, Z equal to 5 square plus 2 square root of, okay, which is 5 divided by 5.385. That value 0.928. Is it lagging or leading? Here I have plus J2, that is inductive load. Whenever we have inductive load, this must be a lagging power factor. If it is a capacitive load, that must be a leading power factor. Now we'll find IPH. What is the current supplied or current passing through the load? So whenever we are finding IPH, make sure we use the phase values. Okay, so all I need to know IPH, phase value is nothing but use the phase voltage and phase impedance. Okay, so phase impedance of phase voltage, if I have line to line value, so here I have line to line value as 208 volts. What is the phase value? So VPH must be VL over square root 3, which is 208 over square root 3, which is 120 volts. So this is 120 divided by 5 plus J2. Okay, so 120 divided by 5.385 at an angle of 21.8. So 120 divided by 5.385 equal to 22.28 at an angle of minus 21.8. Here usually we care for the magnitude, don't worry about the angles here. So P must be 3 times what is the VPH, which is 120, IPH 22.28, and cos theta is 0.928. That will give you the total power. This value is 7444.67 watt. That is the active power consumed by the load as well as supplied by the source, since there is no line impedance. Once I have PS, I need to find QS or Q load. Both of them are same. 3 times VPH IPH sin theta L. So if cos theta equal to 0.928, what is sin theta? So theta must be 21.8. Sin 21.8 equal to 0.371. So 3 times 120 times IPH is 22.28 times 0.371. So the Q equal to 2978.67 volt ampere reactive. That's QS, and SS is nothing but PS, which is also equal to apparent power consumed in the load. PS plus J QS. Here I'm using plus J because I have a inductive load. So the resistor takes P, inductive load takes Q. Okay. If I have a capacitive load, it would be minus. So 7444.67 plus J 2978.67 volt ampere. That's a complex power. If you want to put it in a apparent power, it's square root of P square plus Q square. That value is 8018.45 volt ampere. That's the S value. Cos theta, usually we always do R over Z, but you can do it by using P over S also. That's another formula to find cos theta. Now, one of the student asked me, I am more comfortable converting or having a YY load, since the load, or Y source and Y load, since the load is already Y, can I convert this delta into Y? Yes, we can convert the delta into Y, but make sure when I convert this into delta into Y, whatever the voltage, the phase voltage appearing across the load, you must have the same phase voltage for the Y load or Y source. So basically when I convert that, the given voltage is 208 volt. That is line to line value. So when I convert this into a YY connection, so this value must be 208 over square root 3. Now I can connect a Y load here. Okay, now if I have this, then we'll end up with everything same as the above. So we can convert a star connected or delta connected source into a star, or star connected source into a delta, but make sure the voltage appear across the load will not change. As long as you keep that, you can make the conversion. Thank you. I'll make another example in another video. Thank you. Or I'll solve another example in another video. Thank you.